how Lockheed built a jet in 143 days, and what engineers miss about speed. Contrarian thinking is not about being a rebel, it's about being surgical, knowing exactly what and where to cut to save the patient. In 1943, the patient was Allied air power. Nazi Germany had a jet fighter, the Messerschmitt Me-262, faster than anything the Allies could put in the sky.
What was that? What the hell was that? It went by like we were standing still.
The US needed a jet, and it needed one now. The industry consensus was obvious. A project this complex would need a large department, layers of oversight, and years of development. Instead, the US Army Air Corps handed the contract to one man, Kelly Johnson, Lockheed's most difficult yet most brilliant engineer. On June 8, 1943, the general handed Johnson the contract and said effectively, "Your time starts now." Johnson personally promised a jet in 180 days. When he showed the contract to Lockheed's president, Robert Gross, the response wasn't celebration. It was a warning. You brought this on yourself. And with that, Johnson was given something far more valuable than resources. He was given permission to ignore how things were normally done. That decision created what's become known as the Skunk Works. Not as a strategy, but as an emergency. This wasn't a clean sheet innovation problem. The British had already flown a jet. The Americans rushed that same engine into the Bell P-59, a prop plane retrofit. The result was underwhelming. It was barely better than the existing aircraft. Meanwhile, the German Me-262 was killing bomber crews at an alarming rate. Despite being so unreliable, it killed 200 pilots in training. Jet power wasn't optional anymore, it was urgent and dangerous. Johnson didn't see this as a design problem, he saw it as a systems problem. The existing aircraft industry was optimized for predictability, not speed. And predictability was now the enemy. So instead of trying to work harder inside the system, Johnson did something more radical. He built a new system next to it. The Skunk Works system. Tiny teams, no middlemen. The first shock wasn't the technology, it was the team size. For the P-80 jet, Johnson started with just 23 engineers and 30 mechanics. At its peak, the entire project only involved 130 people. Comparable aircraft programs routinely used over 1,000. This wasn't austerity, it was a deliberate design choice. Johnson believed that once a team grows beyond a certain size, communications collapse under its own weight. Decisions slow, responsibility diffuses, people stop solving problems and start managing interfaces. So he made the team small enough that everyone knew what everyone else was doing. That constraint forced a second decision. Who was allowed in? Johnson didn't just post job ads or ask for volunteers. He later said, "I simply stole them from around the factory. I wanted people whose work I knew." That line matters, because this wasn't about headcount, it was about trust. In a team this small, one weak link doesn't disappear into the system, it breaks it. But there's a catch. You can't run a hand-picked rule-breaking team inside a large organisation without protection from the top. And Johnson had that. His successor Ben Rich later put it, "The open secret was that the chief engineer walked on water in the eyes of the CEO." That sponsorship wasn't a nice to have, it was structural. Without it, the first time Johnson bypassed a committee or ignored a procedure, the experiment would have been shut down. Small team, trusted people, absolute backing. You remove any one of those and the skunk work never gets off the ground. Communication collapsed in a good way. Johnson was blunt about why this mattered. We never had delays or time wasted with goddamn useless meetings. Engineers and mechanics worked side by side, solving problems in minutes that would normally take weeks of paperwork. Decisions didn't travel up an org chart, they happened at the workbench. And because the project was classified, much of the normal bureaucracy simply vanished. Johnson summed it up perfectly. If you can't do it with brain power, you can't do it with manpower. Speed didn't come from effort, it came from fewer interfaces. Ruthless focus on the objectives. Every Skunk Works project had a single brutal prime directive. For the P-80, it was fly faster. For the SR-71, fly higher. And for the Nighthawk, be invisible. Everything else was secondary. Johnson's defense against scope creep was simple. Lock the specification early. Once the goal was agreed, it became a shield. Engineers didn't need permission for decisions. They only needed to ask, does this serve the goal? That clarity also allowed Johnson to be merciless about quality. Ben Rich later recalled his first encounter. Kelly looked at an air inlet Richard designed and said, "It's about 20% too big. Refigure it." Rich redid the maths. It was 18% too big. No debate, no committee, just correctness. Defending engineering truth, that kind of focus only reveals its value under pressure. And here the pressure was lethal. The P-38 Lightning had a terrifying problem. At high speed, it hit compressibility and became uncontrollable. Pilots were dying. Johnson proposed a simple solution: dive brakes. Test pilots hated the idea. To prove them unnecessary, the legendary pilot Eric Kelsey took a plane up, dove it, hit compressibility, couldn't reach the switch, and lost the tail. He had to bail out, and in the process broke his leg. He immediately became the dive brake's biggest advocate. Johnson didn't win by authority, he won by being right and refusing to back down.